Okay, so we're going levels deeper and deeper into this radio here. So I printed out part of the service manual, and here is the board. This board, look, it's almost life size, isn't it? Right there. My gosh, maybe it is life size. And this verifies, looking at this circuit diagram, verifies. Here's the cable here. This is the multi-wire cable, A to H. So let's say 8, 1, 2, 3, 4, 5, 6, yeah, 8. And here's the A line that we've been fooling with. And you can see it connects here. This is exactly the spot where I resoldered and have been focused on. There seems to be no continuity between this point and the wire cable. So it's definitely going there. There's no doubt about that now. The interesting thing is it connects to this red colored trace. Okay, and the red colored trace goes all over the board. 3 volts, 3 volts, 3 volts. There's 4.9 volts. Oh my gosh, does that say 14 volts? What's that say right there? $14 volts. That's interesting. Where do you get 14 volts when there's only three batteries in here? So there must be a inverter and all that kind of stuff happening in here somewhere to develop the higher voltage. There's 14 there. So what we're going to do is we're going to poke around and try to find some of these voltages. That's going to be the objective of our next attempts to get this thing going. At least see if we can get some more information about it. I'll flip you around to the other side here. There we go. There we go. Ah, I like that. That's a good arrangement. So, I still have the black lead of the voltmeter connected to the wire, to the suspicious wire. And I have this red clip lead connected to it. Last test. There we go. So that proves the voltmeter lead is touching the wire in there. There's no question about that. And on this side of the board, we get nothing. You know, so I think we can be pretty sure that that's a problem. Now we're going to change. Change our setup here. Phooey. I really don't want to disturb that. And I don't think I have another meter that's... I'm a little short for meter leads. Well, we can try this one. It won't hurt. We'll just make them nice and sensitive here. See if I can make that a little more visible for you here, too. Oh, Draper, don't jump up here now. There's too much stuff up here. Don't jump up here. Guess I disappointed him. He left. Now, in the dark here, let's look for the 3 volts. Switch is on. 3 volts should be found. I'm assuming it's 3 volts to a regular ground. Oh, let's clip the ground in. Here we are. Okay. Let's clip the ground onto the negative lead here. Instead of what we're doing. We're all set now. So there should be 3 volts right on that, right there. This is a little bit of what I was afraid of. My meter is so inaccurate here. So my meter's telling me 2 volts. I think it was 1.6 when we measured it with a digital meter. This one's really reading 1.9. Well, that's not 3. 1.9. I wonder if that's what the batteries are good for. Let's I've got dead batteries in here. Let's pop them out. Okay, 2 batteries. I gotta test these with the digital. I have to disconnect this. We can't. Too bad. That's too bad. Can't go without my digital meter here. Watch these turn out to be dead or something stupid like that. Okay, so that's 1.5. Nothing wrong with that one. Whoa, whoa, whoa. 1.4. .4, 1.5 is pretty much 3, not 2. Got a new battery here. Yeah, 1.6. Let's put in a brand new one. Didn't come to life, did it? We'll read that voltage again. Now I can use my digital meter here and get a little more accurate reading. Okay, show me 3 volts. Wait a minute. Well, that's pretty mysterious, isn't it? That's mysterious. What happened? Okay, let's do some more voltage checks here. I didn't do very many. So I'm going to ground one lead of my meter there. I sort of checked one 3-volt reading and didn't get 3. Instead I got 2. So let's repeat that, because I changed the batteries after that. So we should be getting three there. I'm not getting anything. That's interesting. Put a little pressure here. Get a variation. That's moving the entire board. Yeah, look at that. Not sure what that means. We're looking for 3 volts, not 0.2. Wow. Doesn't that tell you that there's some bad connections in here for sure? Where exactly? I don't hear the radio coming to life though. I wish it would. Oh, listen to that. Oh, oh, oh. Something funny going on right in here. There's something that kind of, I can feel the board shifting as I push on it. Almost like, you know, those buttons you push that you push down and they go click. It feels almost like that. Oh, maybe it is like that. Maybe I'm pushing some of the buttons up underneath here. Let's remove that possibility. I'm going to prop the radio up. No, the buttons are up here. There's no buttons underneath. What am I talking about? I'm talking about nonsense. So, I didn't want to push a button there. What I'm curious about is this happening because I'm pushing a board that's pushing a board, and there's actually something underneath moving? So I'm pushing the board underneath. Don't seem to get. I could just go and resolder every one of these wired connections. That's interesting. There's a little bit of warmth in this. What is this? I would guess it's a relay. Could be output transformer. There's a little bit of warmth in it. That's a little interesting too. So why is so much power being delivered to this thing? What is it? Let's find out what that is. Excuse me while I go study my electronic copy of the schematic here. I'll find out what that little box is. Okay, so that's an interesting little device there. That's the DC to DC converter. So one way or another, you're feeding in a fairly low DC voltage, not even 6 volts, 4.5 volts from the batteries, and out of it is coming 25 volts and 10 volts, and those should be detectable. There's a big capacitor right there. I should see 25 volts. Oh, that's interesting. The capacitor's rating is only looks like 6.3 volts. 100 microfarad, 6.3 volts. And what's on here is, if I'm reading it right, 47 microfarads, 25 or 29 volts. Where'd my magnifier go? Here it is. Let's see here. 25 volts, that's the rating, I think. That's a rating of the capacitor. Looks like there's 2 electrolytic capacitors. Probably resolving any hash that's left after this D to D converter is DC to DC converter is done. So let's see if we can find some of this voltage. Sets on. 3 volts. Nothing. 3 volts. That could be what's coming out of these batteries without any boost. It drops more or less to 0. Switch on. 3.45. Oh, look at that. How come it would vary like that? This thing's clicking a bit as I'm moving it. It's shifting in some way. Maybe this guy's got a bad solder joint on it. It'd be great if it suddenly jumped up to 20 volts and the radio came on. That would be really great. Well, we're not getting anything out of it here. So what's that telling you? Maybe these batteries are dead. Maybe my supply batteries are actually dead. 3.6 volts. And it should be well, it should be 4.5, 3.6. Let's check that a little more carefully here. 3.6. I think we need to put some better batteries into this guy here. Let's do that. Oh, you know what? I have a power supply. Let's revert to the power supply. I started out with a power supply and then quickly switched to relying on batteries. Let's go back to the power supply here. So we'll pop it in. Let's monitor the voltage here as we do this. I try to make every observation possible. Or every observation I can think of anyway. So we'll go on what I believe is the output voltage, and we'll put in the power supply. Well, it certainly changed it, didn't it? It dropped it. 290. Let me pull it out again. And it goes up. Huh. Okay. It could be the output of my little power adapter is a little low or something. What is the output of that? Let's take a look. About 5 volts, no load. I'm not sure I can read it. Plugging in right here. Not much opportunity to get on the output there. My sleepy meter. Output of the power supply. So that's what the power supply is putting out under load. Let's jack it up a little bit. Actually set to 3. Now it's 4.5. That is the nominal voltage, 4.5. First we'll check this other point here. Hey, that's probably what's coming out of the charger now. No, the 4 is coming out. Okay, so we're getting a little more voltage coming out of the D to D. D to D. The DC to DC. Come on, radio, jump to life. But we're really supposed to be seeing a much higher voltage there. 18 volts, that's what we're supposed to see there. 18 volts, and the capacitor beside it should be showing us 6. Hey, maybe I got the wrong, maybe I got, me. So this one here is supposed to be a 10 volt 220. And I see a 6 volt 100. It makes me wonder if I'm looking at the right thing. Why would those be so different from the schematic? Here we go. Okay, so I'm thinking that should be 6.3 volts there, and the other spot is kinda up in behind there. I really can't even see it. The other capacitor must be under the board, or what? Okay, they can show us a high voltage there. 5.6 on a red wire. Okay, so where else can I read this 18 volts? Where else can I get at it? Swings up just past here, carries on who knows where. I don't have it on this diagram. I don't feel any heat in it. So there's a bunch of transistors in here. I'm not getting any 25 volts anywhere. Somebody show me some proof that this DC to DC converter is working. Okay, I'll go look some more on my computer screen here at the other circuit diagram pages. Okay, back in a flash. Now, I should see 18 volts on here. 6. And here. I'm not sure what that should be. A lot of 6.8. Well, I'm thinking there's improper voltages coming right out of this supply point here, and sure looks that way to me. I left my circuit diagram in the other room. Well, I think that's as far as we're going to get at the moment.